Hello class, today we're on lesson number 7 in chapter 10 and we're going to go over more on factoring second degree polynomials. Now, Leonard Euler, the man who discovered several polynomials that produce primes up to a certain point, once announced that the number 1,000,009 was prime. Later he discovered that he was wrong and that 1,000,009 can be factored into the product 293 times 3,413. Euler was a great mathematician, or Euler who was a great mathematician, would never have made this mistake if it were as easy to factor numbers as it is to multiply them. Now the same is true of polynomials. Multiplying the two binomials, 2x plus 3 and 7x plus 10, for example, is easy. Simply multiply them. We end up with 4 terms. We add the two like terms and we end up with 14x squared plus 41x plus 30. Now, factoring the polynomial 14x squared plus 41x plus 30 back into the product of parentheses 2x plus 3 and parentheses 7x plus 10 and parentheses, on the other hand, is much more difficult if you don't already know the answer. Now, in lesson 4 of this chapter, we learned how to factor polynomials of the form x squared plus bx plus c. In this lesson, we will apply this method to factoring polynomials of the form ax squared plus bx plus c, in which a is not 1. So we're adding complexity to the x squared, or the monomial to the second degree here, which is the x squared. We're adding a coefficient that's just not 1, which means that we're going to now have several factors there as well. Before, we were just simply squaring, so we only had x squared, or maybe x to the 4th power, and we would simply be able to say x times x, or x squared times x squared. Now we're going to have to also factor that coefficient, and in doing so, it's going to create a little more trial and error. We're going to have to look at all the factors of that coefficient to determine which ones will multiply properly with the factors of the third term, the c term, okay, which is just simply a number has no variable. So let's put up our little block over here. I'll just draw up my block. Okay, I drew up my block there very quickly. Let's look at the page 482, top of 482. And we have here, to illustrate the steps to be taken, we will factor the polynomial 6x squared plus 17x excuse me, plus 5. So let's write that up here. I'm going to write it over here to the right. We're going to focus on the box here. So we're going to have 6x squared plus 17x plus 5. Okay. Now again, let's just take a look at our polynomial and see that we've introduced a coefficient here. And what I was referring to, okay, this is new. What was referring to before is that we would simply have the x squared in this box, and we would simply put x times x, and that was great. We were done with that particular portion. Then we would move on to this area of the problem and try to figure out the factors here. But now we have a 6, and we know that 6 has various factors as well. Okay, so if you look at our illustration here, what they're doing is they're giving you a hit and miss scenario. And again, when we say hit and miss, it's not that math isn't exact, but sometimes finding the answers, we're going to have to do a little bit of guesswork and look at all the possibilities. So it means a little bit of extra work. I think that you will ultimately be able to determine these things if you sort of just examine, you look at the number in the middle. Really, this is the key right here. We're looking at 17. How do we produce a 17? Out of the factors when we add them all together? So think about it. You're basically going to be looking at the possibilities of 2 factors here and 2 factors here, and that when you multiply one of each factor with another here, you're going to get 17. And I'll illustrate that as we go along. So we have 6x squared, and we know the x squared part already because it's going to be x times x, right? I'll go back to reading at the top of page 482. Putting the first and last terms into the appropriate corners of the diagram, we get the figure at the left. Okay, so we have 6x squared, and we have the 5. Let me put my 6 in here because that's what should be there. Okay. And because 6x squared can be factored in several ways, we have more possibilities to consider. We begin by factoring 6x squared as 6x times x. Later we'll try factoring it as 2x times 3x. Okay, so again, we'll go with the x terms. We know that there's always going to be an x term, and let me tell you why. Because we want there to be an x term here and an x term here, right? We have the x squared term, but we know we want these two to multiply to equal an x term that we add that will equal to 17x, right? So we know we have to factor the x's into both binomials. Up here we practically we're creating the factors, and I can't really draw this would be actually like the parentheses, right? And being that everything's positive here, would be adding these things. I think this is something that maybe some have disconnected with, that when we're factoring, we're creating these binomials, okay? So it'll be x times something, or excuse me, x plus something, or something x plus something times something x plus something. So we're trying to get our answers here. Okay, so let me just go ahead and remove these parentheses. So we have our x times x, and we're going to factor as they did. They're going to simply put the 6 here, which means 6x times x is 6x squared, and that's correct. Now, what are the other possibilities we have? Well, when we factor out the 5, we really only have two. Well, we have 1 times 5, but we have two opportunities. We can place the 5 here, right, and place the 1 here. But what do we get when we do that? Well, we're going to have 5 times 1 is 5, but we would end up with 5x. Excuse me, not 5x. We would end up with 5 times 6x would be 30x. And I can tell you right now, that's already much higher than what we need, because 17x is what we're looking for, and this would have just been 1x or x, so that would have been 31x when we add them. So that's obviously not the answer. So let's go back and remove this 5 and say, well, what if we put the 5 here and the 1 here, and now we would multiply 5 times x, that would give us 5x, and 6, oops, excuse me there, 6x times 1, that would be 6x. Now when we add these two, we only get 11x. So it's apparent that the factors 1 and 5 are not going to work. So we have to go back and take a look and find out what might work. We have here, just reading along, basically we did what they were saying here in this next paragraph, that the middle term was not adding up to 17x. So factoring 6x squared as 2x times 3x instead, and filling in the factors of 5 both ways, we can possibly find that answer. So what we're looking to do now is go back even further. Okay, so let's just pull this back out, pull out the 6, and say, well, let's try 3 and 2. So we're going to put 3 up here and 2. And it really doesn't matter. I mean, it will matter ultimately when we're multiplying. Again, we could have a 3x here, a 2x here, excuse me, a 2x here and a 3x here. Ultimately, we'll end up with the right binomials that we're going to be multiplying, or the right factors. So again, now the question is, what if we put 5 here? And if we put 1 here, again, these are the factors of 5. And what makes this particular problem a little bit easier is that, again, we're only dealing with the two factors of 1 and 5. This number could have various factors as well, which means this problem is going to become that much more complex. You'll have to do a lot of detective work, figuring them out and trying to find the right combination of numbers that are going to unlock the puzzle, so to speak, or give us the this term here. And in this particular case, we're looking for 17x. So let's do this math. 2x times 5 would be 10x. 3x times 1 would be 3x. And that adds up to 13x, and that's not the answer. So let's go ahead one more time and reverse these. Now, this really is our last opportunity if we're dealing with just integers, and that's what we're dealing. So we certainly hope this will work. Otherwise, it'd be prime. So what do we have here? Again, 3x times 5. That will be 15x. And we have 2x times 1. That would give me 17. Oh, excuse me. I just jumped the gun because I know what it's going to add up to. That will be 2x, and when we add these two together, we get 17x. So what are our factors? Well, our factors would be, and you can write them either way, 2x plus 5, right? That's what we have here on this side. And on the other side, we have, and that should be an arrow, the factor of 3x plus 1. So put my little equal sign, and this is equal to this. It's equal to these two binomials. So we factored this polynomial 6x squared plus 17x plus 5 into these two binomials. Okay, and now to arrive at this result, if we look at the very bottom of page 482, to arrive at this result without drawing any diagrams, we could reason as follows. So we're going to do like this horizontal method, and the first thing they do is they factor out and that first term, and I'm going to get us a cleaner board here, at least on this side over here. I'm going to pull this out and start again with the factoring. Oops, don't want to get rid of that. Okay, so what they're doing here is they're simply creating the same opportunity to factor, but you're doing this in a different method without the box. I really like the box because it's just so much neater and cleaner, and I think once you get used to doing this and doing this math in your head and seeing and your mind sort of wires the pattern into your thinking and understanding that you're multiplying here terms and getting these two terms, and if you can start visualizing this a little more where these terms are coming from, if you can do that in your head, it becomes a lot easier. But here again, instead of putting it into a block, where we can just go ahead and use the binomial itself and say we have 6x and x. Okay, so it's basically what we did before when we had 6x and x up here, and then you start thinking in terms of the constant over here, the 5, and saying, well, to get that I have to have, we know this is going to be plus, everything is plus up here. The minute we get a negative here, it really changes things again. That just adds another level of complexity, but we know this is simply going to be a positive, so we can go ahead and say 5 and 1, and then we start thinking, as it shows here, trying to combine these factors. And we would multiply again the same way. We'd get, if this were 5 and 1, we'd end up with the scenario where this is 11x. Why? Because we would multiply 5 times x and 6x times 1. When we add those two together, we'd have 11x. So it's really the same thing, but you're just doing this horizontally. And if you feel more comfortable using the boxes, then do so. I think that you will eventually work your way towards this as you get further into math. You'll be dealing probably less with the box because you're just going to become that much more proficient in this. So let's just take a look at what they did over here. They said they factored the x now into the x squared term into 2x and 3x. We're near the top of page 483. And then they played around with the constant, and they finally got the answer of 2x plus 5 times 3x plus 1. And so that was pretty much how they did it. Now they have another example here on how to do this horizontal method. I'm going to clean the board up here. Just add a new board, and let's go ahead here and put 7x squared. So we have 7x squared, and we have plus 12x, and that's minus 4. Okay, so here we go. We have a minus. So now we have to think positives and negatives, and adding numbers to equal 12. I'm sorry, that's a 12x. So using their method, we could start with the horizontal method. And again, we would have done, what would we have done here? Oh, we would have just popped the 7x squared here and the negative 4, and then start working these terms around, right? Well, what we're going to do here is do the same thing. We would have said, let's say, as they show, 7x and x, right? So we would have like 7x and x. I'm just showing you both together at the same time. And then we'd start factoring that negative 4. And what could negative 4 be? Well, it could be 1 and negative 4. It could be negative 1 and 4. It could be 2 and negative 2. So they're going to go with the 1 and 4 first. Okay, so they say plus 1. All right, and then they kept the plus here and put the negative 4, and that's fine because we know that's ultimately going to be x minus 4. But let's say we did that. So if we did, then we'd put the 1 here and the negative 4, and that would multiply to be negative 4, right? And same thing here. We would use the FOIL method. So now we start doing our multiplication, and what would we have? We would have negative 28 x, and this would be x. So we know those two do not add up to 12, so that didn't work. So let's pull out these numbers and go to our next set. Oop, I can keep the plus in there. And they went with negative 4 and positive 1. So that means the negative 4 would go here, goes with the 7x, and the positive 1. And again, I just think off the top of my head, 7x and negative 4, that's not going to work, right? 7x and negative 4x, that's going to give me positive 3x. That won't be my answer. So again, let's look at our next possibility is having, and that would be turning over to page 484. Okay, and we've well, they're just showing how what's working and what's not working in the end here. Let's go with that 2 and negative 2. 2 and negative 2. So we can go with 2 here and negative 2 here, and that would give me negative 14, right? X, and this would give me positive 2x. Now when I add these two, I would have negative 12. I said, oh, that doesn't work. But then I see that if this were positive and this were negative, that would work. So it's really just a matter of where these two are. That it's definitely going to work. The question is which one's the positive and negative. So if we changed again, just getting rid of that, and let's put the negative 2 over here and the positive 2 here. Okay, so let's put negative 2 here and positive 2 here. That would give me 14x, and that would give me negative 2x, and when I add these two, I get positive 12x. So our factors would be, and again, I would rewrite this to be simply 7x minus 2 times x plus 2. So we factored this polynomial, and we've addressed the issue now of having the complexity of two different numbers or two different terms, and particularly the coefficient, this number here, creating the complexity that is going to make us have to plug in and use trial and error to ultimately find the answer. So that is the end of lesson number 7.